Hi students, today let's learn about mirrors. In this video we will be learning about the basic and the important concepts of mirrors, basically the spherical mirrors. Okay, let's start from the very basic. So what are objects? Objects are those who give out light or they reflect light. So objects can have their own light like a candle, or they could be reflecting the light from any other source. So what are images? So when light rays coming from the object is reflected from a mirror or are refracted from a lens, an optical image is formed. So the light coming from the object strikes a mirror or a lens, and the reflected rays, they meet at a point. So we get the formation of an image. So either they are reflected or refracted from a mirror or a lens. Now there are two kinds of images, real image and virtual image. Real images are those images which are formed when the reflected rays actually meet at a point. So they give rise to real image. Let's see about virtual image. Virtual images are formed when the reflected rays do not meet at a point, but it appears to meet when the reflected rays are extended backwards. So actually the reflected rays are not meeting, but when we extend them backwards, they meet at some imaginary point, and at that point the image is formed. So it is called a virtual image. Okay. Now see this diagram. This diagram gives us an idea about how an image is formed on a plane mirror. So we have the object here, and these are the incident rays. We have two incident rays here. They are striking the mirror at this point, and these are the reflected rays. So now see, these reflected rays are not meeting anywhere. They are just moving away from each other. But when they are extended backwards, they meet at a point and an image is formed. So this image is a virtual image. Now images formed in a plane mirror are virtual images. We have seen it just now. So object and image formed are equidistant in the mirror. So see, we have the object here and the image is formed here. So this distance is basically, they are same. So the distance of the object from the mirror is equal to the distance of the image from the mirror in case of plane mirrors. And then the image formed is laterally inverted. That means the left side appears to be the right side of the image. The left side of the objects appears to be the right side of the image. So we can see this by an example. So this is how the ambulance is written on the vehicle. It is written laterally inverted way. So whenever we see, suppose we are driving a bike or we are driving a car and an ambulance is coming from back. So when we see in the side mirror, we get this impression. So this part is laterally inverted and we see the actual text written in the mirror of the vehicle. Now a plane mirror changes the direction of the incident ray only. So the incident ray which is striking the mirror, it can be reflected, that's all. So no other changes is done by the mirror. Okay. So any ray which is striking the mirror, plane mirror, will be reflected back. Now let's see what are spherical mirrors. Actually spherical mirrors are made up of a hollow sphere made up of a very thin glass. So you can see in this diagram, this is a hollow spherical mirror made up of very thin glass. Now this is the whole sphere. Now when we cut this sphere in two halves, see we have shown it like this. When we cut this into two equal halves, we get this kind of mirrors. So this can be a concave mirror, and the other part can be a convex mirror. See the shape So this concave mirror and convex mirror both are a part of this hollow spherical mirror. So since they are being cut from the same spherical mirror, their center of curvature will be same and their radius will also be same because they are part of this original sphere. So this hollow sphere is cut into two equal parts. So one part becomes the convex mirror and the other part becomes the concave mirror. And since they are coming from the same mirror, they'll have the same center of curvature and they'll have the same radius also. Okay, now see what is center of curvature. Center of curvature is the center of the hollow sphere of thin glass from which these two mirrors have been cut. So the concave and the convex mirror are cut from a single spherical mirror. So the center of curvature is basically the center of that sphere of thin glass. So the center of this sphere, which is hollow and is made up of a very thin glass, is the center of curvature. And since these two mirrors are cut from the same sphere, they also have the same center of curvature. Okay. Now let's see the radius of curvature. So it is the radius of the hollow sphere from which these two mirrors were cut. So these mirrors which are cut from this hollow sphere, they will have the same center of curvature and they will have the same radius of curvature. See, they have the same center of curvature and they have the same radius. Okay, now let's see what is pole. The pole is the center of the spherical mirror. This part which is marked P here. So this is the center of the spherical mirror. So this is called the pole. So the mirror is from here to here and the pole is the center. From here to here we have the mirror and this is the center part of the mirror. So this is called the pole. It lies on the principal axis. Now this XY is the principal axis. The principal axis is a straight line passing through the center of curvature and the pole of the spherical mirror. So this XY line is passing through the center of curvature and the pole. So this is called the principal axis. Now focal length. Focal length is half of the radius of the curvature. So focal point is half of the radius of curvature. That means half of the radius of the sphere. It is the point where all the rays after reflection converge or appear to diverge. So it converges in case of concave mirror and it diverges in case of the convex mirror. So focal length will be the radius of the sphere divided by 2. Okay. So which is clear from this diagram. So this is the half part of the sphere and this is the another half part of the sphere. XY is the principal axis. C is the center of curvature. This is the radius and P is the pole. So these points are very important and we have to remember. Now concave mirror and convex mirror. See what is the difference between them. The major difference is what we have shown in the diagram. The center of curvature is in front of the mirror in case of concave. So it is a concave mirror and the center of curvature lies in the front of the mirror. In case of convex mirror, the center of curvature is lying on the back of the mirror. So this is the incident ray which is coming and this will get reflected from here. It will strike the surface and reflect. Similarly, this will strike the surface and reflect from here. So the Center of curvature is on the back of the convex mirror and the center of curvature is on the front in case of the concave mirror. Now let's see the sign convention of the spherical mirrors. All the distances are measured from the pole of the mirror, which is taken as the origin. Now if you see this diagram, so this is the pole of the mirror. So now this is taken as the origin for measuring any distance. Okay. Now distances which are in the same direction of the incident light are taken as the positive directions. Now you see in the diagram, this is the direction of the incident light. So these are the incident rays. So they are coming from left to right. So any direction which we measure from the pole in the direction of the incident light will be taken as the positive direction. So the incident rays are coming from left to right, and from the pole this distance is from left to right. So this is taken as the positive direction. Now if we are measuring any direction from right to left from the pole, that is this direction. So this will be taken as the negative direction because this is moving in the direction which is opposite to the direction of incident light. So this is very important, and this is very much required when we are solving numericals. So we have to be very careful while choosing the directions. So all the directions which are in the same direction of the incident light are taken positive, and all the directions which are opposite to the direction of the incident light are taken as negative. Okay. Now the distance which are measured upwards and perpendicular to the principal axis are taken as positive. Now see in this diagram, this is the object, and the object is perpendicular to the principal axis, and the height of this object is upwards. So this will be taken as positive. So any distance which is taken upwards from the principal axis and is perpendicular to the principal axis is taken as positive. Now if you see in this diagram, we have an inverted object here. So this is perpendicular to the principal axis, but it is downwards. So this will be taken as a negative direction. So when we are taking the height of this object, it will be negative, and the height of this object will be positive. So this is very much required while solving numericals. So the distance of the object which is upwards and perpendicular to the principal axis is taken as positive, and the distance of the object which is downwards and perpendicular to the principal axis are taken as negative. And the other convection is all the objects should be placed on the left side of the mirror. See in this diagram, this object has been placed in the left side, and this object is also placed in the left side of the mirror. So when you are trying to find the image for this object, so we'll have to keep the object on the left side of the mirror. Okay. So students, we'll close the session here. I hope you have understood all the basics of spherical mirror. In the next video, we'll see how images are formed in the spherical mirror. So if you like this session, please share and subscribe. Thank you.